today's objective is looking at calculating average rate of change and also relating that idea to what slope is. So in our first example here, we have Alex and Jamie. We want to know who is moving faster and how we know. Well, we have it arranged on the graph, and we said with our graphs, you always want to make sure that you identify what you're working with. So we can see that we're measuring the time in seconds as our inputs. That represents our independent variable. And our output is being measured in meters. That's our dependent variable. So who's moving faster? In order to determine that, there are a couple things that we could do. Visually, we could look at the lines on our graph and see which one is steeper. Then we can check it with doing the calculations. It appears that the line for Alex is steeper than Jamie's. So that implies that it would be a faster rate. Well, let's check the calculations behind it. Alex is starting at the point 0, 0. So the distance at the definite start, time is not started yet. Well, over the course of 5 seconds, Alex has now traveled 150 meters. So what does that mean for us? If Alex has traveled 150 meters in 5 seconds, that means the rate of change for Alex is 30 meters per second. Now we have to find Jamie's. So if you notice, Jamie at time 0 is already starting 20 meters away from Alex. Over the course of 10 seconds, Jamie has traveled to 120 meters away from where Alex is at. Well, Jamie started at 20, ended up at 120. Therefore, Jamie has traveled 100 meters within the 10-second time period. Well, 100 meters in 10 seconds means that Jamie has traveled at a rate of 10 meters per second. So, who's traveling faster? Alex has the faster rate of change at 30 meters per second. So again, we've proven that he's moving faster. We also say graphically, because the increments are the same on the graphs for the time in seconds, right? Counting by 30-second intervals, counting by 5 meters on both graphs, we can also see visually that the slope is steeper for Alex. Now I'm using the word slope because there is a constant rate of change. Remember, the line has a constant rate, so no matter what 2 points I picked along the line, the rate would still be the same. It's consistent all the way through. So when you have the same rate from any 2 points on your graph, we often refer to that as slope instead of rate of change because the average rate of change is consistent. Now, that may not always happen on your graphs, so we have to be careful when we're using that term slope versus average rate of change. Now, we know it's not always graphs that we're given to work with. Sometimes we have tables. So for number 2, who is growing faster and how do you know? Is it Justin or Aubrey? So looking at the tables, we want to think, what are the inputs, what are the outputs? What are the inputs, the independent variables, the outputs, the dependent variables? So inputs would be age, and we can see that the age is going up for 1 year for Justin and the same for Aubrey. The dependent variable would be the heights, and so we want to see how are those changing, and are they consistent from year to year? So let's take a look at Justin. I'm going to go year to year, and I can see that Justin's height is 4 centimeters every year. Because it's a constant rate of change, I can say the slope for Justin is 4 centimeters per year. Now for Aubrey, every year she has a change of 4 centimeters. Again, because it's the same, we can say that the slope is 6 centimeters per year. So they have a constant rate of change, both Justin, 4 centimeters a year, and Aubrey, 6 centimeters per year. Who's growing faster? Well, Aubrey, because her rate is 6 centimeters per year, 2 more centimeters than Justin. Let's look at another scenario. Michael started a savings account. After 4 weeks, he has $350 saved in the account. After 9 weeks, he has $400 saved. What is the rate of change of money in his savings account per week? So again, just like we did for the graphs in the table, we want to identify the independent and dependent variables, or the inputs and outputs. So our inputs, the independent variable, would be the number of weeks. Our outputs, the dependent variable, would be the dollar amount saved. So if we're trying to find the rate of change of money in the savings account per week, just like we did for our height problem with Justin and Aubrey, we're going to look at the change of the outputs compared to the change of the inputs. That's the same as what we did for our graphs with Jamie and Alex. So the outputs is the money, right? So $400, $350, what's our rate of change there? 9 weeks to 4 weeks, what's our rate of change there? Well, 400 minus 350, that's $50, and 9 minus 4, that's 5. So $50 in 5 weeks was the change. How does that boil down per week? That's $10 per week. So from week 4 to 9, Michael saved $10 per week. That is the average rate of change. Now, we don't want to say that that's the slope because we don't know what happened the first 3 weeks or what happened after 9 weeks. The rate of change could be different. So that's why we're going to say the average rate of change over weeks 4 to 9, that interval, was $10 per week. So we looked at a table, we looked at a graph, we looked at a scenario. Let's do some more practice. Here we have a camp scenario. In 2007, 70 kids attended summer camp. In 2011, 58 kids attended summer camp. What are the variables that are being compared? So we're trying to determine what would be our inputs, our independent variables, and our outputs, the dependent variables. It goes back to the two items being discussed. One is the year, and the other is the amount of kids. So we know the independent variable is the year, and the dependent variable is how many kids attended summer camp. Inputs, outputs. Well, what would be the rate of change for the attendance? The change of the outputs, let's think, 58 to 70 from 2011 to 2007. So 58 minus 78, that is negative 20. 2011 minus 2007, that is 4. So over 4 years, 20 less kids attended summer camp. What does that mean on a per year basis from 2007 to 2011? That means 5 less kids attended summer camp each year. So as we write our summary, we can say 5 fewer kids attended summer camp each year from 2007 to 2011. Now, if this was your business, it's a good way to keep track of things to see what would need to change to increase attendance, right? Or at least at minimum, not have a change of attendance. So that's why average rates of change are important. Let's try another. Here's a scenario of temperature versus time. Time is being measured in minutes. This is our independent variable, our inputs. Temperature, these are our outputs, the dependent variable, and it's measured in Celsius. Our question, first off, is what's the rate of change from 9 minutes to 17 minutes? Well, on a graph, let's locate where that's happening. At 9 minutes, we know the temperature is 120 degrees Celsius. And at 17 minutes, that's 70 degrees Celsius. So what's the rate of change? Well, we're going to compare the change of the outputs to the inputs. So a change in temperature versus time. So 70 minus 120, that's negative 50. And 17 minus 9 is 8. So over the course of these 8 minutes, in the interval from 9 to 17, there was a loss of 50 degrees Celsius. Now, we like to always get it down to 1 unit increments. So what does this mean for 1 unit? So if we continue to simplify, some of you maybe divided out the common factor of 2 and got it to 25 degrees lowering in Celsius over 4 minutes. But again, to the 1 unit, that would be a loss of 6.25 degrees Celsius over the interval from 9 to 17. So as you're writing your final summary, that's what we want to incorporate. The temperature decrease at a rate of 6.25 degrees Celsius per minute over that interval from 9 to 17. Well, what about this one? What's the rate of change from 17 minutes to 20 minutes? Again, identify where they are in the graph. And the rates of change is always comparing the outputs, the dependent variable, to the inputs, the independent variable. So the change in the temperature to the change in the time. So our change in the temperature to the change in the time, notice there was no temperature change over the 3 minutes that passed. So we could say that it's 0 degrees for every minute. This is representing your constant interval where it has a rate of change of 0. So we can say that there is no rate of change over the interval of 17 to 20 minutes. So as we can see with this situation, not all the rates of change are the same depending on what interval you're looking at. So here we have a rate of change of 0, which would also occur over the interval from 2 minutes to 9 minutes. We could also see that we had 3 decreasing intervals at different rates of change. So we have to be very careful when they're specifying the interval, how to find the rate of change for your problems, versus when it's consistent, like in our example 1 and 2, when it's consistent like that, we often refer to it as slope. So now it's going to be your turn. Oops, we got one more to go. Sorry about that. Let's do one more with a table. So here we're looking at a bank account with the months and the balance. We want to find the rate of change between months 6 and 14. Again, first off, you have to identify the variables. What's your independent and dependent? Our independent variable is the months, and our dependent is the account balance, and we're measuring that. So what's the rate of change between 6 months and 14 months? We're going to identify 6 to 14 and use those accordingly. Well, from 6 to 14 months, that's a change of 8 months for the inputs. And for the outputs, that's a change of $8,000 less, right? Negative 8,000 for the 8 months in question. Well, for every month, that means you lost $1,000 in your balance. So the rate of change would mean you lost $1,000 a month from 6 months to 14 months. Now we don't know if it's consistent because if we looked at it per month in the table, our balances are different. So this would not be one that we refer to as slope. We would have different rates of change because, as you know, especially when we're talking about bank accounts, regardless of the dollars for measuring that in or pounds or the unit of measurement, it can fluctuate based on a variety of things. So here we're just focusing on this interval and we have the rate of change accordingly. So now it's going to be your turn to practice with your problems on rates of change and slope.